So here we are going to do number G together. And then you will come and do number I as your classwork, number K as your classwork. H and J is going to be your homework. And then what is it that we are doing for number J? For number G. Okay, we'll do number G together. And then for number G, we are going to determine the equation of the asymptotes. Now, since we are talking about a parabolic function, we are going to have two equations. So we're going to take number G. And on number G, we say we have G of X, which is given as 4 all over X minus 3 plus 2. And then you will have number 1 for that. On number 1, what is it that they ask us to do here? We are determining the equations of the asymptote. Okay? Now, how do you determine the equations of asymptote? Based on what we learned yesterday, we said we are going to say X minus 3 is going to be 0. Okay? And then if you take this minus 3 to this other side, it says which you're going to have what? You're going to have what? Then you're going to have X is going to be equal to what? To positive 3. Okay, now we want to get Q here. Now, what is Q? Q is the one which is not with the fraction. Any value which is not with the fraction is going to be our Q. So the one that is not with the fraction is going to be our Q here. Now, in this case here, we have plus 2. It's not with the fraction again. Now, guys, the other thing that you should know is this equation could have been written this way. It could have said G of X is going to be equal to 2 plus 4X minus 3. They could have given it just to us this way. Now, what is our Q if they gave it to us this way? It's 2 again. Yeah, the one which is not in the fraction is going to be our Q value. So nothing has changed. So we have the one with the fraction, and then we have the one which is not in the fraction, then that is going to be a Q value there. So we'll come and say, okay, here we know what is our Q value. So based on what we know here, we'll say which Y is going to be equal to what? To 2. So these are the equations of the asymptotes. Now, what did I show you yesterday? I said we should be able to take these values and represent them again. Let's go and represent these values then. If we go and represent this one, think of them as our electric fence. We cannot go beyond them. Our graph is not going to be able to go through this thing here. So what we are going to have here, we have X is what? X is 2. X is 3. Okay, we come here and say here X is 3. We shade it. If we shade it here, and then we're going to have a vertical line. X is 3. So we're going to put a vertical line here on X is 3. Okay, now the other one that we have is the Y one again. Y is 2. Yeah, here we're also going to come and put the horizontal line. Now, what the vertical line and the horizontal line do is to create where we are going to draw our graphs. So we have 4 spaces in which we can draw our graphs. We can draw our graphs here, we can draw our graphs here, we can draw our graph here, we can also draw our graph here. Now, since we're dealing with a hyperbolic function, we're always going to draw 2 graphs. Now, our graphs, they always go in pairs, unless they stated otherwise, they can restrict the graph. If they didn't restrict the graph, our graphs are going to go in pairs. So after you have the vertical and the horizontal, then you are going to have 2 graphs. Your 2 graphs can either be on the first and on the third. And then I'm using what? I'm using the vertical and the horizontal line again as my guide. So this thing here, the vertical and the horizontal line, it divides into 4 parts. Can you see that again? On those 4 parts here, you're always going to draw your graph on 2 instances. So you can either draw it on the first and the third. If I don't draw it on the first and the third, I can draw it on the second and on the what? On the fourth. Is that clear? Okay, now that we have this one, and then we did this one since yesterday, the next thing that we can do now is to determine the x-intercept. Oh, we can determine the y-intercept. It's not the first time you see a word saying y-intercept. And then, from what you know, how do you determine the y-intercept? What? We want y-intercept. If we want y-intercept, we are going to say this is our number 2. If we want the y-intercept, what are we going to say? X should be 0. So it means which we are going to have y is going to be equal to 4 all over 0 minus 3 plus 2. Are we together then? And then from here onwards, I will say don't try to be a hero. Don't. So you simply type this thing in your calculator. If you type this in your calculator, it says which you have 4 all over. And then it says 0 minus 3 plus 2. And then you get what? You get 2 all over 1 all over 3. Now, usually I would say, let's leave our answer here. Okay? Now, I'm not going to leave my answer here because I need to draw this thing here. Since I need to draw this thing here, I am going to check what is this thing here. This thing here is going to be 0.66666. Then it's going to be 0.67. We still find it. Okay, now the next question says we should calculate the x-intercept. Now, if you want to calculate the x-intercept from your experience, how do you calculate the x-intercept? You should let y to be equal to what? To 0. Okay, let's let y to be 0. It means we are going to have 0, which is going to be equal to 4 all over x minus 3 plus 2. We want to get x again. Now, if you want to get x, what we're going to do first is to take this 2 to this other side. Okay? If we take this 2 to this other side, what are we going to have? So we're going to have minus 2, which is going to be equal to 4 all over x minus 3. Now, you want to get x again. Okay? Now, if you want to get x, the next thing that you will do, what is it that you will do here? If it was you, you will cross multiply. Okay? So if you cross multiply here, it says which you are going to have minus 2 multiplied by x minus 3, which is going to be equal to what? To 4. You still want x again. How would you get x? You can FOIL again. Now, if you don't want to FOIL, you can divide because multiplying and division, they are inverse of each other. Again. So if I want to avoid this issue of saying this one multiplied by this one, I think that this one is the simplest. You just multiply throughout again. Now, if you multiply throughout, then you're going to have minus 2x again. And then you say this one multiplied by this one gives you plus 6, which is going to be equal to what? To 4. And then you take this 6 to this other side again. It says we have minus 2x, which is going to be equal to minus 2 again. And then you divide by minus 2, you divide by minus 2. It says which x is going to be equal to what? To 1. Okay, now let's say which you didn't want to do it that way then. You could have said here, from this step here, if you didn't want to FOIL, again, multiplication and division, they are inverse of each other. You could have said, okay, let's divide both sides by minus 2. And then we divide by minus 2 again. Minus 2 and minus 2, they're going to divide each other. If those two divide each other, you're going to be left with x minus 3, which is going to be what? Minus 2. Okay? And then if you take 3 to this other side, you're going to have positive 3. Okay? And then it says we have minus 2 plus 3, which is going to be x is equal to what? To 1. Then between the two methods, now you decide which one is going to work best for you. Okay, now, after this, we are supposed to draw the graph. That is our number 4. On number 4 is which we draw the graph. Before we can even draw the graph, we need to go and represent the x-intercept and the y-intercept. Now, your x-intercept and your y-intercept are your gates. Your graph cannot go through this line. Your graph cannot go through this line except on the x-intercept. Your graph cannot go through this line except on the y-intercept. So what do we know as our x-intercept? Our x-intercept was given as 1:0. So we come and shade, which here, this is a gate. So it's like I'm opening a gate here. When you're going to draw your graph, guys, when you're going to draw your graph cannot all of a sudden pass here. It can't. The only space that it has, the only gate that it has is the x-intercept. So the x-intercept is your gate. This is where your graph is going to be able to pass. If your graph, let's say your graph is coming from this side here. Your graph, it wants to pass and come this side. It cannot go this side except here. This is the gate. Does that make sense? Okay, here. Then we are going to open our gate. If our graph is from this side here and then it wants to pass through here, it needs to pass through the y-intercept. So we need to know what is the y-intercept. So if we go and check there, what is our y-intercept? We got it as 0.67 again. So we'll come and open the gate there. So if you come here and then you open your gate is going to be at 0.67. So here you have 0.67. Now you have a gate, and then after having a gate, you have fence. A fence, you can't go through the fence again. You can't go beyond the fence. What are going to be your fence? These are going to be your fence. So you have this thing here is your fence. This one here is also going to be your fence. Now I said to you, your graphs, you're always going to have 2 graphs again. Your graphs are always going to be in pairs unless it's restricted again. Now, yeah, already you have 1 on the third. Can you see that? You already have one graph on the third. Automatically, it makes the other graph is also going to be on the first. So it's something that you should know. Agree, our x-intercept, they already guided us here to say which we already have one on the third. Because we have one on the third, the other one is also going to appear on the one on the first. Is it fine? Now, another way, maybe if you really struggling here, maybe you can look at it here. The value of A. You can come and check the value of A here. The value of A is going to tell you which way are you going to draw your graphs. So here you have your vertical asymptote and then you have your horizontal asymptote. So you are going to draw first and check if A is positive. If you come and check here, what is the value of A? A is positive here again. So it's going to be on the first and on the one on the third. And then here, if your A is negative, for example, here you see A is negative here, or then you can put the negative here. If your A is negative, then you have it on the second, on the one, on the fourth. It's something that I'm not going to cram because I want us to use the table method. So it's not something that you should worry about. Let's go and use the table method. If we go and use the table method, how do I get to the table, by the way? If I want to get to the table, how would I get to the table here? I go to mode. Okay, mode, and I check the options again there. And then the option that I'm going to choose according to my calculator again. My calculator, it says I'm going to choose option 7. Yours is possible, but you might choose option 3 again. Okay, option 7, and then you're going to type this thing exactly the way it is. So if you type this, you are going to put it in a fraction. So you say you have fraction, we have 4. All over, you are going to have alpha x minus 3 again. And then you go to an arrow, and then you say plus 2. We are done again. So you've put your values there. Now, what do you want to do next? You want to determine where are we going to start, where are we going to end. So here we're going to say, okay, equals to. And then they ask us where do you want to start again? Where do you want to start? I say like, the rule, you can start anywhere. The rule is you can start anywhere. But what you want to do is to include everything which is here. You want to include everything here. You want to include the red dots. Right? You also want to include this green thing here. Why do you want to include the green, not the horizontal one? It's because according to your calculator, when it asks you where do you want to start, it's asking you about x. They're asking you about the x values. They're not asking you about the y values. So the rule that I usually use is to say, I am going to look at the vertical line. At the vertical line here, I'm going to use 3 values before the vertical line. And I'm going to use 3 values after the vertical line. That is my rule. It's not to say which you should use it, but it works. So I'm going to check here, okay, here. If I have 3 here, I want to include 3 values here. I will say 1, 2, 3. Then I can start here. I can start on -1. I can start here at 0. I want to have 3 dots after. Before I want to have 3, and then after I also want to have what? I want to have 3. So let me start at -1. So if I start at -1, and then they ask me which way do I want to end. Now I am going to tell them I want to end 3 dots. I want to end 3 values after the vertical line. So if I want to end 3 values after the vertical line, I'm going to say 1, 2, 3. So where am I going to end? I'm going to end at 6. So I will say here I want to end at 6 together. And then step, I'm going to leave it as 1. And then I'm going to start with this thing here. It says which when x is -1, when x is -1, what is going to be our y? It's 1. So here it is. I'm going to shape this one. I want 3 dots. Remember, what did I say? I want 3 dots again. Okay. Now the next thing, when x is 0, what do I get? 0,6. 0,6 get this one again. So I'm going to connect these 2 dots. So if I connect this one and this one. And then the next one, it says which when x is 1. What x is 1 is what? It's 0. And then after that, it says when x is 1, what do we get? When x is 2, when x is 2, we get -2. So we'll come and shade this one. Now, guys, here, this is not a rule, guys. The rule, it's like whenever you should make sure which it gives you the shape. So make sure which you have 3 dots, 4 dots, so that you get the shape, which how is the shape going to look like? I'm not going to tell you which start here, don't start here. When you should check here, with at least have 3 dots. What I've seen is that 3 dots can give you a shape, which what kind of a shape you're going to have. Now, yeah, this is your gate. I can't pass anywhere except through the gate. Even if it's not there on the graph, even if the x-intercept was not there on my graph there, I'm going to pass through the x-intercept. Actually, I started by shading the x-intercept. So I'm going to pass through the x-intercept. Now, from here onwards, here, I am going to say, okay, my graph is going to be approaching this green line. It can't touch this green line. It's approaching it. And then my graph is also going to be approaching this orange thing here, but it can't touch it. Now, check what happens on 3. When we go to 3, it says with error. It tells which you are done with the first graph. It tells you which you are done with the first graph. Now we are going to start with the one with the second graph. So if we go and start with the second graph, it says which when we have 4. What is 4? 4 goes with what? 6. Goes with 6. So we come and shade this one here. We have 4, which goes with 6. Okay. So we have 4, which goes with 6. So here it is. And then when we go to 5, 5 goes with what?
5 with 4.
With 4. So 5 goes with 4. And then 6 goes with what?
6 with 3,33.
It's 3,33. So we have 3 dots now. We can connect these 3 dots. They're going to give us the shape, the kind of shape that we're going to have. And I'm connecting them using my freehand again. Now look at what I cannot do. I cannot go beyond this green line. I can't go beyond this green line. So I'm just going to put an arrow to say this thing here is going to continue there. And then the other thing that I've seen is like, I cannot do something like this. My graph is not turning, guys. It's approaching that green thing, but it can't touch it. Can you see that again? It's approaching it, but it's not going to touch it. So yeah, I'm simply going to say I'm approaching the green line. Without touching the green line, I can't touch it. I'm approaching the green line, but I'm not going to touch it. And then from this side here, I'm not approaching green, but I'm approaching the orange one again. So I'm going to approach the orange one, but I cannot touch it. And then this is how my graph is going to look like. Now from here onwards, then this is you then. We said we're doing number I and K again.